Summarizing qualitative data. Here's a data set that consists of 25 people's eye color, where we have blue, which is BL, brown, which is BR, black, which is BK, and hazel, which is H. So to summarize the qualitative data, we would like to construct what we call a group frequency table. So when we construct a group frequency table, we will set up a table that will have columns of the variable. So here I'll go eye color. The next one will be frequency. This is going to be our counts. And our last one will be a relative frequency. And then the data form the rows. So here we have blue. So I'll just write BL. Hazel will be the next one. Note there's no ordering or ranking. Just put in whatever order you want. Black, BK. And then finally brown, BR. And then at the very bottom, we'll put in a total, just to verify some things. Alright, so now all we do is go through and count how many blues we have. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the frequency here, we'll go 9. Hazel, 1, 2, 3, 4, 5, 6, 7. Black, 1, 2, 3, 4, 5, 6, 7. There's actually supposed to be one more. For some reason it doesn't want to show up. So here we'll have 8, and then finally brown, which is 1. And note if we add this up, we get 25, which is how many data that we had. The relative frequency is computed by taking the frequency and dividing it by the total. So for the blue, we take 9, divide that by 25. So when I do that and then multiply by 100, or move the decimal to the right. So when I do that, 9 divided by 25, I come up with 36%. 7 divided by 25 is 28%. 8 divided by 25 is 32%. And then finally 1 divided by 25 is 4%. So notice if we add this up, so we get 14, 18, 20, 0, 2, 3, 6, 8, 1. So here we get 100%. Just let you in that this number here is not necessarily going to be 100% just due to the fact that there may be round-off errors. Sometimes it might be a little bit more than 100%, sometimes it might be a little less than 100%. So this is our group frequency table for categorical data, and this is all that we will do. Summarizing quantitative data. We're going to discuss 3 ways of summarizing quantitative data. One is going to be a single value approach. The second will be what we call a limit grouping approach, and then finally the third one is going to be a cut point approach. With the quantitative data, kind of overall, we talk about grouping the data together into what we call classes or bins. After determining the classes or bins, we count how many data fall into each one of the classes. Once we have the counts or the frequencies, we can compute the relative frequency. So an important note, all the classes must be disjoint, that is, they can have nothing in common, and every piece of data has to fall into one and only one band. Let's take a look at our first one, a single value grouping. The values themselves form the classes. So just like on our eye-color data set, we had blue, black, brown, and hazel. Just like each one of those individual ones formed the class, if you will. In this case, we're just going to use numbers. This method is used when the data is discrete and is also used when the data set has a small number of values. By this, we're meaning a small range of values. Okay. And now let's take a look at constructing a group frequency table for a data set. And this data set, I pulled a class. And in this class, I asked my students to state how many siblings that they had, not including themselves. And this is the data that resulted from this particular class. So we should have 34. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 8 times 4 is 32. 3, 4. Yeah, got them all. And this is I sorted the data for this presentation. Normally the data would not be sorted. Okay, so let's form a group frequency distribution for this data set. So in this case, we will use, let's see, siblings. And again, we'll go frequency. And we will go relative frequency. Now let's just take a look that this is discrete data set, and notice that there is a small range of values. We're only going from 0 to 7. And then according to our previous slide over here, remember that it said that the data values themselves will form the bins. So right here, the data values themselves will form the bins. Okay, so that means that each one of these values will form our bin. So we have a 0, 1, 2, 3, 4, 5, 6, 7. And again, we'll do a total. So then all we do is count. So we have 1, 0. And then if we count up all the ones, you can see that we have 10. Count up all the 2's, we have 14. Count up all the 3's, we have 4. Count up all the 4's, we have 3. Count up all the 5's, we have 1. We have no 6's, and we have 1 7. And again, if we add up the frequency column, this will total out to 34. The relative frequency, again, we take 1 divided by 34, so when we do that, we get 3%. 10 divided by 34, we get 29%. 14 divided by 34, I get 41%. 4 divided by 34, I get 12%. 3 divided by 34, we get 9%. 1 divided by 34, we get 3%, which we had up here at the top. This one is 0% and 3%. And again, if we add up all of these, we end up with 100%. So single value grouping, again, is when we want to, when we have our data set. Notice that our data set here is discrete. And notice that it has a small range of values. Okay. The next example we'd like to take a look at is using what we call a limit grouping. And in this case, we are actually going to use class limits. We're actually going to form some bins, a range of numbers. And we are going to, with the range of values, we do have what we call a lower limit and an upper limit. And we'll discuss that, demonstrate those. And this is used when the data is primarily integer value or discrete again, but we have a large range of values. So 3 important guidelines here is that the number of classes by rule of thumb should range between 5 and 20. Each observation, again, has to belong to one and only one class. And whenever feasible, the bins should be all of the same width. Okay, so let's take a look at seeing the data when we have these exam scores here. So here I have 30 exam scores. Okay, and in this case the data is already sorted, so that helps us out. Okay, so now what we would like to do is to form our group frequency table. So I'm just going to move this up. And again, the idea is that we're going to do the exact same thing that we've been doing. So again, we're going to create a table. So let's just call this exam. And then here we'll have frequency. And over here we have relative frequency. Okay. So to bin the data up, we have to have a starting point. In this case, the lowest value is 56. That's a straightforward starting point, but it doesn't have to be the lowest value. If I wanted, I could go to 55 or 53 and choose that. And the next thing we need is a width or a bin width. So I am going to choose a width of 9. So this will have me have these classes. I will have 6 bins. So let me go ahead and just draw these lines in here. 1, 2, 3, 4. So starting with 56, I'm going to go 56 up to and including 64. And then I'm going to start this one at 65. And this one is going to go up to 73. The next one is 74. This will go up to 82. And then the next one will go from 83 all the way up to 91. And then we get 92 all the way up to 100. And then finally our last bin is going to go 101 all the way up to 109. Now I'm keeping my bin widths all equal. Remember, it says whenever possible, keep the bin widths equal. But notice that my largest value is 104. That means I could stop that bin at 104. So now notice that a couple of things. One, this is the lower limit of the bin, and this is the upper limit of the bin. And when we want to check the class widths, we have to take the difference between the lower limit in one bin and the lower limit of the next bin. So notice if I take 65 minus 56, I have 9. So the bin width is 9. And then I keep doing that for all of these, and notice that all of them will have a bin width of 9. And so now it's right back to doing what we've done before. Just count up how many numbers fall between 56 and 64. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In our next row, we go up to, looks like 73. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm sorry, we only have 7. Got a little excited there. Then the next one, 74 to 82. So we get 1, 2, 3, 4, 5, 6, 7, 8. 83 to 91. 1, 2, 3. 92 to 100. 1. And 101 to 109. We get 1. So that's our frequency. And again, our relative frequency, we have a total of 30 exam scores, so 10 divided by 30. So that will give me 33.3%. 7 divided by 30 will give me 23.3%. 8 divided by 30, 26.7%. 3 divided by 30 gives me 10%. 1 divided by 30 is 3.3%, and the same thing here. Okay, and then again, if we add these up, these percentages, notice that will only come up to 99.9%. Again, it is 100%, it's just due to round off error. Cut point grouping is similar to the previous limit grouping, but this works when our data set consists of numbers that are decimal points. So real numbers, not just integer value numbers. In the previous slide, notice that we had integer values on our previous example, and notice that we had a large range of values as well. So we went from 56 all the way up to 104. And notice that that is a pretty wide range of values, so it's a good idea to go ahead and bin those data. In this case, when we have cut point grouping, is usually it will be done when you have real numbers. So let's take a look at an example. So the cut point grouping, here is our example with fuel tank capacities. So this is a data set of 35. So to do the cut point grouping here, I want to notice that the smallest value here is 12.5. So with that 12.5, we will choose a starting of 12, and I'm going to use a class width of 2. So let's just take a look, and let's go ahead and set up our table. So we'll have class, frequency, and our relative frequency. So starting at 12, I'm going to go 12, and here, just to keep things in mind, and the next value is going to be 14. So the way I'm going to do this is 12, under 14. What this basically means is 12 up to and including, up to but not including 14. Since I'm not including 14 here, I will include it down here in my next bin. So 14 up to and including, I'm going to use this symbol, 16. So remember, we're not going to include the 16. 16 up to but not including 18. 18 up to but not including 20. 20 up to and not including 22. 22 up to and not including 24. 24 up to and not including 26. And then finally 26 up to and not including 28. Because I believe our largest value, where would our largest value be? It's in here somewhere. So it looks like maybe 26 is our largest value. Okay, so that will get all the data covered from the smallest to the largest. So again, all we do now is just scan through our data, and 12 to 14, so let's see, 12 to 14, so there's 1, 2. So 12 to 14 we have 2. 14 to 16, do these a couple of times here. 14 to 16. 14, so there's 1. 14 to 16. 2, 3, 4. So I have 4. I'm supposed to have 6, so I'm missing 2. Okay, so let's just say 6. And then from the 16 to the 18, if we do that, we'll have 7. And the 18 to 20, again, if we go through, we should have 6. And the 20 to 22 is 6. And 22 to 24 is 3. 24 to 26 is 3. And then finally 2. And then we can do our total. And this should add up to however many data points that we have, which I believe was 35. Yeah, 35. Okay, and then finally our relative frequencies, again, 2 divided by 35, so here we get 5.7%. 6 divided by 35 is 17.1%. 7 divided by 35 is 20%. And next one we get 17.1%. 17.1%. And then with the 3 we get 8.6%. 8.6%. And with the 2 again we get 5.7%. And then add these up, get about 100%. Alright, so that is summarizing and displaying data video part 1. In part 2 we'll actually go back and discuss how to construct graphs for these data, for each one of these data sets.